Hello everyone, welcome to the fifth lecture on C++ programming language. And in this lecture we are going to talk about type modifiers in C++. First, type modifiers. Then we are going to talk about auto keywords in C++, and then we talk about constant in C++, constants, how we can define a constant in C++, and fourth we talk about, or last one we talk about comments on C++. So let's start with type modifiers in C++. In the previous lecture, we studied about variables and data types in C++, and I explained that variables are used to hold value or data or store information on computer's memory. So we use a variable to store the values, and also I explained the data types on C++, and the data types are used to define what kind of values you are going to store on computer memory. So we started like integer, integer, we started float, we started double, we started char, bol, string. But when we talk about type modifiers, it means we have first we have signed, we have unsigned, then we have short, then we have long. So signed, unsigned, short, and long, they are called type modifiers in C++. As you can see, the name says modifiers. So what are type modifiers? What are their objective? Their objective is they bring changes on the size of a data type. They bring changes on the size of data type or in the range of values a data type can store. Let's, for example, if we define a variable int a is equal to 10. So this is a variable. A is a variable which stores 10. So this is an integer variable. It means the size of this variable is 4 bytes, because integer, when we say integer, when we talk about data types, they are not only just talking about the type of information we can store in computer memory. Also, they define the size of a variable. So if we say integer a equal to 10, it means this value 10 is stored on the memory, and it takes 4 bytes of data. 4 bytes of data in memory, because the integer size is 4 bytes. If we define this, double x equal to 20.5, so the size of double is 8 bytes in C++. When we define float, the size of float is, a float variable is 4 bytes. When we define car, the size of a car variable or char variable is 1 byte. When we define the bool is, the size of the bool, the data type is 1 byte. So when we define the data type, also the data type besides says that this variable x store floating point numbers. Also it defines the size of the computer memory. So it means this 20.5 stored, it takes like 8 bytes of our memory, 8 bytes of our memory. So when we talk about the sign, means this variable by default, like a, This variable by default stores positive and negative numbers, positive and negative values. So when we say int a equal to 10, we can say this 10 can be positive or negative. Negative also we can say minus 10. So now the value of a is minus 10. So when we say sign it, we always remember we put the sign it or type modifiers before the data type. So we have first type modifiers, type modifiers, type modifiers. Then we have, data type. Then we have variable name. And then we have, equal, like the value of a variable or semicolon. So when we say sign it integer y is equal to 10 or 100, it means the y can store positive numbers, negative numbers, and also zeros. So it can be minus 100, or it can be 0, or it can be 100, which is a positive number. So the sign modifier is used to, if we use this before a variable, it means we have this sign modifier before variable y. It means this y can store negative values, positive values, or also zeros. But when we define unsigned, like we defined unsigned integer, suppose integer age, the name of the variable, age equal to 20. So now when we say unsigned integer a equal to 20, means the variable age only can store positive numbers including 0. So it can store 0 or positive numbers. So when if we put here minus 20, so there the compiler will give you an error here. It says this variable is defined unsigned. It means only this variable can store positive values, because we need it sometimes to store positive values, like our age. Our age cannot be negative. Our age cannot be negative. We become 20 years old, 20 years old, 5 years old, like 50 years old or 60 years old, whatever we are. So it cannot be a negative value. So when you need it in your program to put like a positive value, store a positive value inside the variable, you need to put before the data type of that variable unsigned modifier. So then we have here modifier of short. What it means, if we define a variable called integer z equal to 25. So the integer tells the data type and the size of the memory this variable can store. So it means this variable can store whole numbers, integer numbers, and also the data type says the size of the memory this variable takes. So it is 4 bytes. In C++, when you define an integer variable, it allocates the 4 bytes of the memory for that variable. So when we put short here, now the size of this variable is not 4 bytes. It's not 4 bytes. It's become 2 bytes. It becomes 2 bytes. So it actually, the short, decrease the size of the memory which is allocated for a variable. So once like age we can we have like the person who has now, I think, the most like 130 years old, or 120 or 110 or 105. So we don't have like 2008, someone with the age is like be too big number. So we don't need a big number for the age. So when we define a variable called age, so we define short int age equal to like 50. So this is the short identifier. Then we have the long identifier. If you want to store, a large number, we use, like long modifiers. Like if you put in front of like a variable, if you have, integer, let me clean this one first. If we put here long integer x equal to 10, so now the size of a variable x is not 4 bytes, it's 8 bytes, because if you put a long in front of a variable, it increases the size of the memory for that variable. If you have big numbers to store, so we use the long. If you have small numbers, so we use the short. If you want to a variable can store positive and negative numbers, we can use the sign it. If you want to a variable can only store positive numbers, we use unsigned it. So this is the type modifiers. So type modifiers actually change the size and the range of a value of a variable which can store. If you use short, it means it decreases the the size of the memory for that variable. Like if a variable integer is 4 bytes, so it decreases to 2 bytes if you put a short. If you put long in front of integer, it increase the memory allocation for that variable, which become 8 bytes. So if you need for large numbers, and if you use to store negative and positive numbers and zeros, so we use signed integer. But sometimes in our program we need it only to store positive numbers, like like age. So we can use unsigned integer age. So these are all the four data type modifiers or type modifiers which I introduced here and explained. So now let's go to the auto keywords. Another auto keywords, in C++, introduced in C++ 11 or in modern C++. So if we define if we define a variable in C++ and initialize a value on that, we say integer number equal to 100. So we defined a variable called number, and its data type is integer. It means this number can only store whole numbers, and the value which is initialized or stored inside this variable is 100. If we see out this, so if we see out, it will print out the 100. So it means when we want to use a variable, we have to declare that variables. We have to define the type of the variable first. Like if you want to store a floating point number, so use double number 2 is equal to 20.022. So this is a double. So we define the data type of a variable when we declare a variable or initialize. But the auto keywords, when we use the auto keywords which introduced in modern C++, so we don't need actually to define the type of the variable. So we say auto z equal to 50. So in this case, if we don't define the the data type, so the C++ compiler define the data type for these variables, because we put it auto or automatic. So what it means, the compiler sees the value of this variable. It sees if it is a whole number, so the compiler automatically define the type of this variable int. In this case, it's int. If we have another variable, if we define another variable auto I say temp equal to like 200.5. So once the variable the compilers come and see this line, it comes and check the value of those variables, and it says this is floating point numbers and double numbers, so the type of this variable become automatically defined by compiler double. So it means you don't need anymore to put in front of a variable integer or float or double. You can use auto. Auto, like auto name. Auto name equal to Mike. So now when the compiler sees the value of this variable is string, so or text, it automatically define the type for this variable as string. So actually it is it depends on the compiler, and the compiler determines the type of variable based on the value or the value which we initialize for that variable. So this is the auto keyword. So after this, if you don't want to use integer like int or double or char or string, so you can use just put auto. And be careful when you put auto, so you have to initialize that variable. It means because the variable that the compiler determine the type of the variable based on the value. So you cannot say auto x and semicolon. No. So when you declare the variable type auto, at the same time you have to initialize also. Otherwise the compiler give you an error, your program will not execute and compile. So now let's go to the constant, the third subject, which is constants. Sometimes in our programs we need a value that should not be changed during the execution of a program. Like in mathematics, we have a constant of pi. Yes, we have a constant of pi. Pi is equal to 3.14159. So this is the value of pi. This is a constant, and this value will not be changed. So in this case, if we define a variable, so variable as the name suggests, like yes, it says variables, it means the value of a variable can be changed during the program. Like if I have here integer x equal to 10, I can say cout x. Now here in the screen we will see 10, but we can change the value. We can say x is equal to 1001. Now if we cout x, the value of x is now 1001. So it means the value of a variable can be changed during the program. So we can change the value. It's called variables because we can change the value of a variable. So now if we want to define a constant and the variable which the value should not be changed during the program, so we use the keywords. We use the keywords const in C++. We have const. Like if I want to have double pi is equal to 14159, and I want to, this value should not be changed during the program, I put here a const keyword. So now if in another line, if I say pi is equal to 5.5, so the variable gives you an error. It says this pi is defined constant here. You cannot change the value of a constant. So suppose if you have a developed system, like you authenticate the users, like user should enter username or password. So we can define a constant, says const number of attempts, const int number of attempts equal to 3. It means if a user enters the username and password 3 times, define incorrect. 1 time I enter my username and password, I cannot log in because the system says username and password is correct. Then the second time I enter username and password, the system gets, okay, your username and password is not correct. And the third time I try, so in that case the system says username and password is not correct. When I try the 4 times, so I defined here a constant. It says if number of attempts become 3, disable the the login page, because one kind of attack we have called brute force attacks. The attacker guesses the username and password. There's difference, like the name of the person as a username and the password is the the date of birth of the person. So it tries multiple times. So in this case, there will be a security, like consideration, like you say, const integer number of attempts equal to 3. If number of attempts become 3, so disable the login page. So the attacker or the person who tried to, broke in the system, he cannot enter anymore, the username and password. So that's, we use const for these situations. So now let's go to the fourth subject of our today's lesson. It's comments. Comments in C++ are used to explain the code. So we have comments. We write comments on our code to explain the code. Okay? Or we first explain the code. Explanation. If you want to, explain a line of code or explain a class or explain a function, so we put, a line, we use comments. Then if you want to, at the beginning of your program, you write a comment and it tells the objective of program, what this program doing. So that's also we use comment. 3, we can use also comment for debugging. It means if our program, debugging, if our program has errors in some lines, we don't know in which line of the program is error, so we comment every line and then compile or run the program, then comment the second line, compile, then comment the third line. It means that line will not be compiled or executed. So comments are not compiled or executed by compilers. They're only used to, for code readability. So I write comments for my codes because if 10 years later I came here, or 5 years later I came here and changed the source code of the system, I should know what this line do, I should know what this line does, So like if I write here, integer x is equal to 100. So I can write a comment here. This line initialize value of 100 to x. So in C++, we have two kinds of comments. We have single line comments. In C++, we have two kinds of comments. Yeah, one, single line comment. Single line comments, which the name says it comments a single line of code. It means it starts with, double forward slash. If our compiler sees double forward slash, after that there will be a comment until the end of the line. Like I can write here this is a comment. This is a single line comment. This is a single line comment. And we have multi-line comment in C++. Multi-line comments. And multi-line comment starts with slash star, and it will comment multiple lines. So we can first line, second line, third line, then we have it ends with star forward slash. So this is called anything you put inside this, forward slash star and star forward slash. So it will be considered, comments, and the compiler will not execute. And this is single line because if you continue these statements to the next line, it will, generate an error because this line, this double forward slash tells the compiler that this one is a single line comment, and the compiler will not execute till the end of the line. And after that, if you continue your comment, it will be, an error. So now it's time for practice, and let's go and practice this lesson on the computer. Thank you. So thank you for joining in this course. So we are on the 5th lecture, and I'm going to first open the code blocks. Yeah, so we can create another project, create new project, console application. And then next, we select the language C++, the project names, like I put lecture, lecture-5, and click next, and finish. So our project is created successfully. So yeah, in this lecture, we talked about first type modifiers in C++, and and type modifiers in C++ change, uh, the size of a variable, or the range of our, the value a variable can store. Change the size or range of values a variable can store. So I can go to settings, editor. So change the font size. It is now choose. It is 18. I put 16. Okay. So you can see. So we have, four different type modifiers in C++. One is, signed. Another is unsigned. Another is short, and another is uh, long. So let's go and see an example from signed modifier. Signed, when we use the signed modifier in front of a variable, it means that variable can store, positive values, negative values, including zeros. So we can say uh, positive values, okay, positive, negative, including zero, okay? So that's we use, or uh, the sign modifier. So let's, for example, if we say signed integer x is equal to, oh, sorry, equal to 100. 100. So now we can see out and say x is equal to x n line. So if we compile and run this program, we can see the output what it says. Yeah, so we can see the output. This val this x variable can also use, negative values, can also store negative values, like I can say minus 100. Hmm. Yes, it's minus 100. So when you want to, store negative and positive values, include zero, you can assign it. You can put the sign it, modifiers from the variable. Now we talk about, unsigned modifier. The unsigned modifier, when we put an unsigned modifier in front of a variable, it only can store positive values and zero, including zero. So when we put unsigned, suppose if we put here, like I can change this one now. So we have a integer x is equal to minus. So I remove the minus and I put here unsigned in front of this variable. I put unsigned. And now we compile and run our program. Yes, compile and run it. Yeah, now x is equal to 100. But if I put in front of this minus 100, let's check what happens. Because we told the compiler that this variable, which is x, and the data type is integer, which can store whole numbers, only can store, positive numbers. So now run it. You see? Do you see the value of x is now has been changed? Because this variable only, this is a garbage value, and this variable only can store positive values because we put it unsigned. Like we can say, if we define like if we define our age, if we need to store our age, so we say unsigned integer age is equal to 30 or 50. Now see out, you are age years old. End line. And now we can run this program and we can see, because age cannot be negative. So it says you are 50 years old. So we can put here space, one space. So during the development, we face, sometimes a situation we need to declare a variable unsigned, which only can store, positive numbers. Like, another example, like if I open the paint, if I open the paint, if you have a square or if you have a rectangle, if you want to calculate the environment, the perimeter or the area of this, area, if you want to calculate the area of a square or a rectangle, or maybe you know mm, mm, a circle, so it cannot be zero, because if a circle is zero, so it doesn't have like perimeter and area. And the circle, the area of a square or rectangle, or the perimeter of a square or rectangle or circle cannot be negative values. So if you develop a system which calculates the perimeter and area of a square, circle and rectangle, so you have to validate the user data. When the user enters a value, you have to check if it is negative, so we cannot calculate. So in that case, you need to define unsigned, like radius. And for the radius, you can define unsigned, or you put unsigned modifiers. So that was the unsigned modifier. Then we have short. Short is another modifier in C++. I write comment because the comments, the compiler when sees the comment, so it ignores. It cannot compile and execute this line. So because this is a single line comment. So the short modifier decrease the size of a variable, or memory size of a variable. Let's check it, okay? If like if we have integer, the size of an integer is 4 byte, okay, in C++. If we suppose have integer age is equal to like 10, and then we have to check the size of the integer. So we have a function called size of. We can say size of integer, okay? So we can say n line. So let's put here, let's put integer size. Int size is, then we write this one. And now if we compile and run this program, int size is 4. 4 means 4 byte. Okay, if you can see, int size is 4 byte. If we define a variable like double y equal to 20.5, and now we check the size of this variable, so we can say, I can copy this because I don't need to type actually. So I can copy and says the size of this double sizes size of double. I can put here and just check it. So double size is 8. So now if we check if you put this one float, now we check the size. Oh, it is it's double, so we can say float. And also we put for float, you put an F here, because if you don't put, the compiler will automatically change that one to the C++ compiler to double. So put a F. So let's see, float size is 8. So it means the size of, oh, sorry, you have here float. You have to change this one also. So I forgot to change the double. It was printing the double size. But now the size of float is 4 bytes. You can see if you define like a character char, which is, char c is equal to store the value of c. So the size of the, if I write here uh, char size of char is 1 byte, okay? Size of boolean is also 1 byte. You see? So now if I want to, if I just, remove this two, and I can remove this two also, I only put this here. So if we put short in front of integer, now if we run the program, let's see, in normal situation, the integer size is 4. If we put here short a modifier in front of the name of, in front of integer variable, so now let's check it. Integers, oh, sorry. So it's short int age equal to 100. And now if we put here short, this is the size of integer, but we put here short, or we can remove, even we can remove the integer from here. Oh, sorry, Control Z. We have short integer age message before, but we put it here integer. We have to put here like the age variable because age variable is now short. So now let's run the program and compile. You can see now int size is 2. Why? Because now we put it in front of integer, we put it short. And now the size of age, this variable, which is stored in computer memory, is 2 byte, not 4 byte. But if we remove this one, look, if I remove the short, so you can see it become 4 again. You see that? Yeah. And now if I back put the short, so it decreased the memory size of variable. It's 2 byte now. But if you want to increase the memory of short, we use the long. So let's do that. Long now. Let's check. The integer size is 4. Now because this one is long integer age, but now if we put, like if I remove the integer, the long size, it's still 4 byte. Okay. So if I put long, let's check in this situation. We can use long as a data type also. It's become 8. You see, it increases. Increase the value of variable. Like if we have here, we can define also like even we can define like a variable short, like short age mm, equal to 20, or we can say double long salary is equal to mm, like 12,000. So now we can say size of the age. So let's check the size of the age. It's now 2 bytes because we defined it the short. We don't need to put even the integer here. And let's check the size of, salary. If we, Mhm. It's 4 bytes. But if we change that, we put another long in front of this. So it became, 8 bytes. Yeah. So it means in this memory, in this variable, we can store big numbers. So this was, the short and, the long, which was the long was increase of memory size of a variable, memory size. So this was the type identifier. So now let's go talk about utu. If we define a variable, integer, number is equal to 10. So the type of this variable is integer, and we can see out this 10 or the number. If we see out, it's a 10, yes? So I can use, like define this. We have a function called type div. Type definition. If I can put this function, so you can dot name. Let's check it. hmm And I will include in our program. I include this. We have a stream, so I include another one. I should include type div. I think it was type div. Let's check it. If it's not, it will generate errors. So let's run it. Yeah, it says type div. Yeah, compiler says error is in line 2. The type div no such file or directory. Okay. Okay. So let me clean this. Now let's compile it. Compile and run it. So it will say is like we do not error expected primary expression before type div. Like there is a type definition. So let me check what was the name. Ash include. Yeah, type info. So now let's run it. Let's compile and run it. So sometimes, this is the type diff. I think this one is type ID. Yeah, type ID. Sorry. So now if we run this, let's check it. It says I. It means this variable is integer. Okay. So the number variable is integer, yes, because we define it. We put it the data type of integer. But if we define a double variable, double x is equal to 12.12. And now if I define the type of this variable, so let's type id of x, yes. So now if we run the program, we see double. These double I is for integer. But if we use o2 instead of integer, let's put o2. Now compile and run. Yeah, the compiler automatically assign, the type of this variable because we use the uto keywords. And this, the uto keyword was introduced on C++11, and you don't need anymore to define the variable, data type if you put the uto. And the compiler automatically assign or define the type of this variable based on the value we initialize for the variable. It's 10, so it's a whole number, so the compiler assign for this, integer. But this one, look, this one, let's define this one uto. Let's see. Yeah, I and D. If we have like say uto, like the uto char, we don't specify char. Uto later equal to like a. We don't define, the data type. So now if I print this, see out, I use type, ID function, type ID. Okay, so now I put here the later, so I can define, the type ID function is used to define the variable type. Dot name, it means print the name of the type. So inline. And now if I run this program, we see, yeah, the type of the variable, later is char, which is means C. And so the compiler automatically detects now the type of the variable later based on the value, which is character, and the compiler assigned the character data type for this variable. So this was the explanation about O2, and now we go and define the constant. So the constant is used in C++ because we need sometimes to our variable should not be changed. Like if I define here, like it says u2 or integer, let's say integer a is equal to 100. And now if I see out says, I say a is equal to, I print the value of a, okay? Now we run this program, we see the value of a is 100. But if we later we change a is equal to 2000. And now if I print the value of a, so it says a is equal to a n line. So now if I print this, a became 2000. It means the value of a variable can be changed during the program. But sometimes we do not need to change the value of a variable. It's called constant. So we define the constant, unchangeable. So it defines a variable which is unchangeable. So we cannot change the value of a variable, cannot be changed. So how we can define this unchangeable values or immutable values? So the value of a const will never change during the program. So if we have like let's here I put a const like const integer max is equal to 100. And also please remember the name of const in C++, should be capital. It means if we define max in capital, means in somewhere when we print someone else see your code, it defines that it recognizes that this max is a const variable. So the value of the const will not be changed. So now if we see out, we say max is equal to max and line. If we run the program, so it will print out, this 100 value. Yes, that's correct. But what happens if we change the value of the max? We say, like I change the value of the max here. It says max is equal to 50. It's not 100. So now if we run and compile, the compiler says in line 14 there is an error. It says here error assignment of read-only variable. So it says the max variable is a read-only variable. The value of the max cannot be changed. It's not write-only variable. It's read-only variable. It cannot be changed. So it gives you an error. So once you change the value, it will generate an error, and the program will not compile and will not run. So that's we can use the const mm, we use the const keyword in front of the variable, the value will not be changed. Like we have the pi value, like value of the pi, we say const you know double pi is equal to, let's for example an example, equal to 3.1415. And now if we calculate, suppose the area of our rectangle, so we use the, suppose if we have double radius equal to zero point 0.5, and v double area of a circle is equal to mm, pi multiply, then we can use like multiply this uh, multiply this variable. So we have the formula for that one, pi r square. So we use the formula to multiply these variables. So we can use that one, pi uh, radius multiplied to radius multiplied to radius. Mm, yes, so this is the area. So now if we print out, we calculate the area. So we can say area of circle is mm, area n line. So my keyboard is Swedish keyboard sometimes. So I have to find the right operation. So this asterisk means in C++, multiply. So if we run, we see the area of circle is 90.50304. So in this situation, we use the const variable. and we will later, we practically work more examples, advanced examples. So now let's go to the comments in C++. Comments. Comments in C++ used to explain the code, okay? Explain the code or mm, you know define the object or explain the objective of program, or also you can debug your program, okay? So if you write here, we have single line comment in C++, single line comment, which is start with forward slash, two forward slash. After this, anything you write here, it's comment. This is a single line comment. You see in these examples, I use the comments, but the program never, give me an error. Why? Because the comments actually are not compiled by C++. The C++ cannot, execute or compile, the comments. So it is used for explanation of, poor code. Like you see integer age is equal to 10. So you can write the comment for explanation. The variable age stores 10. So you write a comment for this and explain, like this program calculate in the, the area of a circle. So that's a comment. So we have another comment which is multi-line, but this one is a single line. If I continue, this is another comment. This is another line comment. But now if I execute this program, the compiler give me an error because says if you start a comment with the forward slash, the compiler ignore that line till the end of that line. But if you cut it from here and here, so now it's part of that comment, and the compiler will not generate an error for you. Yes, it's done. Okay. So now if we define the multi-line comments, if we need to multi-line comment, we have slash star. Then we put our comment here, a star slash. So we can put here, this is the first line, and this is the second line. This is the third line. So you just now if you queue and run, so there will not be any error because we commented and the compiler will not compile this part of the code or this part of the code. So this was, mm, uh, today's lesson. So thank you for joining in this lecture, and thank you for taking this video.